Hi guys, and welcome to another video. In today's video lesson, we're going to be looking at Grade 12 Maths Euclidean Geometry, Approach to Problem Solving Past Exam Questions, Part 2. Now, if you haven't watched Part 1 of this video, Part 1, basically, we answered this question 8, and these are the solutions. Now, if you haven't watched Part 1, watch Part 1 because it'll give you an insight into our problem solving strategy, which I'm actually going to continue with in today's video lesson. So let's look at the question that we are going to be looking at today. This question appeared in a past examination paper and it reads as follows. It says, in the diagram, M is the center of the circle. So you are given the center of the circle. So all center theorems need to be adhered to because you know that you are going to use those particular reasons for our statements made. A, B, C, K, and T lie on the circle. AT produced and CK produced meet in N. Also, NA equals to NC and B is equal to 38 degrees. So the first thing that we need to look at is what is given in this particular question. And remember, our problem solving strategy for Euclidean geometry is to solve the diagram as far as possible based on the information that is given. So if I look here very carefully, I would be able to see the following. I have a cyclic quadrilateral A, B, K, T, and I need to know all my cyclic quadrilateral properties. I also have another cyclic quadrilateral which is A, C, K, T. Remember, 4 points which lie on a circle form a cyclic quadrilateral. What are the properties of a cyclic quadrilateral? Well, number one is that the opposite sides are supplementary. The exterior angle of the cyclic quad equals to the interior opposite angle, and also we have angles in the same segment or the line of a cyclic quadrilateral subtends equal angles. So let us now, as far as possible, let us solve this particular diagram. Okay, so based on what we are given. So remember, we are given the center of a circle, which gives rise to the following. Center gives rise to radii. So that's radii as follows. The angle at the center is twice the angle at the circumference. So if that's 38 times 2, so that will give us 76 degrees there. Angle at center is twice angle at circumference. Also, opposite angles of a cyclic quad are supplementary. There we go. Remember, I told you A, B, K, T is a cyclic quad. So 180 minus 38 equals to 142. So here we go. So that's 142 degrees. So T1 is 142. And here we can say that T2 and T1 lie on a straight line. They are supplementary, or you can say T2 is equal to 38. The exterior angle of the cyclic quad equals to the interior opposite angle. Also, if you look here, remember that you have 38 here, and we can say that that also is going to equals to 38 degrees. Exterior angle equals to the interior opposite angle of cyclic quad KTAC or ACKT, whichever way you want to look at it. Remember that they also tell us that NA equals to NC, which means that if NA equals to NC, so we can just put those markings there, then this also will equals to 38 degrees. Equal angles, opposite equal sides. And once again, K4 will equals to A or NAC because the exterior angle of a cyclic quad equals to the interior opposite angle. So learners, as you can see, we have solved most, if not all, of the angles of this particular diagram. And right now we can actually go and look at the questions and see whether we have solved it. So they say calculate with reasons KMA. KMA, let's check if we got it. KMA, what will we write? Let's say KMA equals to 76 degrees, and it would be angle at center is twice angle at circumference. Okay, so we got KMA. T2, T2, so there's T1, T2 is equal to, so we'll say 38 degrees exterior angle of cyclic quad. So we got that one. C, and we'll say C is equal to also 38 degrees, and we'll say that the exterior angle of a cyclic quad equals to the interior opposite angle. So we got that as well. K4, so let's look at K4. So in order for us to get K4, we'll say firstly K4, we will say that A is going to equal to C, equal angles opposite equal sides, because we are given that NA equals to NC, and then we'll say that K4 equals to A, exterior angle of cyclic quad. Okay, so we got K4. Show that NK equals to NT, and here NK equals to NT. Well, basically we got K4 equals to T2 equals 38 degrees. Therefore, these two Kn and Nt must be equal to each other. Equal sides opposite equal angles will be our reason there. And lastly, prove that AMKN is a cyclic quadrilateral. Now, what are the three ways that we can prove a cyclic quadrilateral? Let's just have a look at that quickly. AMKN. So we got AMKN. So we got AMKN. Let's just highlight that very quickly. We got AMKN. And as you can see here, what do we have? So if that's 38 and 38, what do we have here? Let's see. We can solve for n, right? That'll be 180 minus 38 plus 38, 38 plus 38, and that's equal to 104 degrees. So we're at 104 degrees. What do you notice? KMA plus KNT is 76 plus 104. So 104 plus 76 will prove that this is a cyclic quad because the opposite angles are supplementary. So once again, let's remember, in order for you to prove a cyclic quadrilateral, you've got to prove its properties. Opposite angles supplementary, exterior angle equals to the interior opposite angle, and you can prove a line of a cyclic quad, line subtends line in a cyclic quad, or a quad subtends equal angles. So you've got three ways to prove that a quadrilateral is a cyclic quadrilateral, or to prove a cyclic quad. It doesn't necessarily have to lie on the circle. If 4 points lie on the circle, they don't have to tell us it's a cyclic quad. It's already a cyclic quad. Okay, so that's something that you have to take note of. So let's go write our solutions down quickly. So 10.2.1, 10.2.1, KMA, so that's KMA equals to, let's write it down quickly, 76 degrees, 76 degrees, angle at center equals 2 times angle at circumference. B, we'll write down T2. So there's T2 is going to equals to 38, exterior angle of cyclic quad. So we'll say T2 is equal to 38 degrees, 38 degrees, that'll be exterior angle of cyclic quadrilateral. C is going to be equals to T2, so C equals to T2 equals to 38. You can write it like this. I prefer to write it like this, equals to T2 equals to 38 degrees, exterior angle of cyclic quad. And for D, K4, so first we'll write down that CAN, or we can write here So it's rather CAN, so we can write that down for D. Remember, we got equal angles opposite equal sides, and we want to show K4 is going to equals to 38 degrees there, right? So we're going to say CAN. Okay, so there's CAN. It's going to equal to NCA. And why is that so? Remember, we are given that NA equals to NC. So there's NA is equal to NC. NA equals to NC. Therefore, we can now conclude that K4 equals to K4 will equals to CAN equal to 38 degrees. Exterior angle of cyclic quad. And now we got NK equals to NT. We said here, in order for us to show that NK is equal to NT, we know that K4 is equal to T2 equals 38 degrees. So we can just write that down to 10.2.2. You can say here that, let's go back up here, K4 equals to T2. K4 equals to T2, which is equal to 38 degrees, and that is already proven above. Therefore, we can say NK equals to NT and K equals to NT, and that will be equal sides, opposite equal angles. So there you go, NK equals to NT. Proof: AMKN is a cyclic quadrilateral. We said we must use one of these ways to prove a cyclic quadrilateral. That's basically proving properties of a cyclic quadrilateral. And we said that we're going to find KNT first, which is 104 degrees. Let's go and write that down, 10.2.3. So we're going to solve here for KNT. KNT equals to 104 degrees. Sum of angles of triangle, and we already know that M is equal to KMA is equal to 76. KMA is equal to 76 degrees, and that was already proven above. Therefore, we can now conclude that AMKN is a cyclic quad. AMKN is a cyclic quad, and our reason will be opposite angles are supplementary. Notice, and that's our solution, proving that AMKN is a cyclic quadrilateral. If you haven't subscribed already, subscribe to JL Maths, like my Facebook page, Justin Lazarus Mathematics. Also, you can watch all videos in order of the work schedule on jlmaths.com. And I'll catch you in the next video.